Welcome to Fertility and Sterility on Air, the podcast where you can stay current on the latest global research in the field of reproductive medicine. This podcast brings you an overview of this month's journal, in-depth discussion with authors, and other special features. FNS On Air is brought to you by Fertility and Sterility family of journals in conjunction with the American Society for Reproductive Medicine, and is hosted by Dr. Kurt Barnhart, Editor-in-Chief, Dr. Eve Feinberg, Editorial Editor, Dr. Micah Hill, Media Editor, and Dr. Pietro Bortoletto, Interactive Associate-in-Chief.
Hello, everyone. We're here at PCRS in sunny Palm Springs. So happy to be here today with our president of PCRS, Dr. Alex Quaas, and president-elect, Dr. Jason Franasiak. Thanks so much for being here, gentlemen. And Alex, can you please tell us about the shirt that you're wearing right now?
Actually, I literally just got changed out of my suit because I thought that, this is only like audio. And so I thought it was okay to just wear this Superman shirt with a sperm on it. So I got this on one of my first PCRS meetings when I first started coming here in like 2012. So the first meeting was in 2011, but I think this shirt is from 2012 and it's from a sperm bank. And so it's a Superman shirt with a sperm on it.
Well, I think that's a great way to kick off. And I'm here with my co-host, Dr. Micah Hill, and we're so happy to be here. We hope you will all come to PCRS in years to come because it is a really fun meeting and we've learned a lot. Hopefully we can share some of the science with you today. So Alex and Jason, tell us a little bit about what you've enjoyed about this meeting and your vision for PCRS in the year coming up.
Well, Kate and Micah, thanks so much for having us. I think that one of the things that just in general, not even getting into some of the fantastic science that has been presented here, one of my very favorite things about the Pacific Coast Reproductive Society meeting is the venue. First off, it's in Palm Springs, which you really can't beat. But I also really enjoy that the entire conference takes place in one lecture hall. So you're not having to run from place to place. And the program committee puts on a fantastic and diverse slate of lectures, which run the gamut from things that entail IVF to reproductive surgery to reproductive genetics and legal and ethical issues, the laboratory issues. And so as a physician, obviously, I'm not doing all of these things every day, but they all impact the way that ultimately I work to care for patients. And so I always really appreciate even lectures that don't necessarily touch on exactly what I do every day. It really helps as I kind of bring myself back to putting the full picture together of the way that we care for patients.
Yeah, I couldn't agree more that there is a wealth of information and diverse information for our patients and for clinicians alike. So, Dr. Quaas, tell us about your presidential year. How did it go?
Yeah, I gave some opening remarks and I said how much it meant to me to be the president of PCRS because this organization has always been so near and dear to me. So on day one, I got really excited and I thought of all sorts of executive orders, like, for example, like cutting all ties with ASRM, dismantling ABOC because we're all sick and tired of maintenance of certification and things like that. Also, this meeting is way too casual, so to mandate a suit and tie for all attendees and stop this California casual madness. Also, I had a plan to rename Coachella Valley into Pacific Coast Reproductive Valley, and then also ban the term intimate collegiality that had been associated with the meeting, and also designate Rick Paulson, my former mentor, a rhetorical dictator and make him sit in the last row for any future meetings. But then I met with Adam Carranza, who's our wonderful executive director, and he is just so amazing. And he reminded me of the mission statement of PCRS. And basically, it's a global interactive organization that champions the field of reproductive medicine and that we believe in the support of physicians, teams, and allied professionals, innovation, inclusiveness, collegiality, and professional development. And so I changed my mind and I basically tried to just make the society even better. And so the things that we've actually achieved are we've created all these task forces in different areas. For example, we have a social media committee, we have an awards committee, we have a membership committee, and many other committees that have been created. And so that gives people more opportunities to get involved in PCRS. So that's one thing that we've done. And the other thing we've done, because the society is really thriving, and we have actually, we're doing well financially, so we didn't have to increase the registration rates for many years. And we've got more and more scholarships. And one of our plans is to expand the scholarships for non-MD allied disciplines, like, for example, embryology and genetic counselors, nurses, things like that. So I think we've achieved a lot.
Awesome. Well, congratulations. Hopefully you'll have some more time on your hands now, as you're no longer going to be El Presidente, but you've certainly left a great legacy. And Jason, what do you have planned for this upcoming year?
Well, one of the very first things that I had planned to do on Sunday when I took over as president, my very first action was going to be to reverse all of the executive orders from the prior administration.
Here. They left you a mess behind.
Very fortunately, Alex came to his senses very soon after he put those executive orders into place and reversed them all immediately anyways. So for the coming year, Phil Romansky is going to be the program chair for next year. We are putting together a really fantastic group of lecturers. We actually next year will be transitioning. The conference has been held at the Renaissance Esmeralda for a number of years, and we're transitioning over to a new venue at the Westin Ocho Rios. It's a fantastic venue. The conference will have the entire property, which is fantastic. So we're really excited about a couple of those things. The program is a little bit of a secret just now, but we'll be putting that out shortly, which will be a lot of fun. And I'm just really very honored and excited that the Pacific Coast Reproductive Society has allowed an East Coaster to come in. I've been coming to this conference since I was a first-year fellow in 2014, and over the years, it has really become kind of a second home for me. So I'm just very grateful for this opportunity.
Well, we're grateful to both of you for leading us and for providing such great meetings. Jason, I know that you are great at coming up with themes and naming things. So we look forward to a really ingenious name and theme for the meeting next year.
Yes, thanks, Kate. I appreciate you pointing that out after just 5 minutes ago, me telling you that I was terrible at it.
There was one highlight of the meeting, Alex, I was hoping you would address, which was Richard v. Richard. Which round was this? Round 5?
Well, it was a second round at PCRS, but like the first debate when I was the program chair in 2017 was the first debate, and then they took it on the road and went to do almost like a tour. And I think they spoke or debated the use of PGT-A in Asia, India, and many other places. And also they had a fertile battle that was published in August of 2018 in Fertility and Sterility. And so I really enjoyed the debate 8 years ago because Rick Paulson is near and dear to me, and he was my fellowship director. And then Richard Scott, of course, is a pioneer of PGT-A. And to see the two going at it and debating the use of PGT-A with great scientific sort of evidence, but also metaphors, including, of course, the famous football analogy that Rick
we call it soccer in this country.
Oh, that's right. Sorry. Yeah. And that's right. But the soccer ball looks more like an embryo than an American football. That's right. But yeah, so to see them go at it again was just priceless to me because they're both near and dear to me. But also, I think a lot of people commented that they have sort of come a little closer, like the meeting 8 years ago. I think it was more polarized. This year, they actually agreed on more things than they disagreed. So that was interesting to see.
Yes, maybe they could teach our leaders, the leaders of this country, a little bit about agreement.
That's right.
So thanks.
Partisan agreement.
Thanks so much for that. And again, have a fantastic rest of your meeting.
Thank you so much.
Here with doctoral candidate Shannon Rainsford from Yale University broadcasting again here from sunny Palm Springs. Shannon, thank you so much for joining us today. We really loved your presentation on protamine 2 deficient sperm. Tell us a little bit about your work.
Yeah, thank you so much for the opportunity to talk more about my work, as well as PCRS for letting me talk. So my work focuses on protamine 2 deficiency, specifically in mouse sperm, and how this can ultimately impact fertilization as well as embryogenesis. So I'm interested, and our lab is interested, in how protamine ratios could lead to infertility and what role they play in fertilization as well as in embryogenesis. So something we know is that there's a complete epigenetic change that happens in paternal DNA from spermatogenesis to fertilization and up to pre-implantation development.
So Shannon, tell us what was your research question that you addressed in your talk?
So I wanted to understand a little bit more as to what the molecular drivers of infertility are, or specifically what can help cause male infertility. Because we have physical ways of assessing embryos as well as sperm, but we have very little understanding what's quote unquote happening under the hood, or what's happening inside sperm. And protamines are an incredibly important part of sperm that help compact DNA. And so I wanted to see whether or not changes to the amount of protamine 2 could actually impact embryo development.
Awesome. So you looked at protamine 2 deficiency in mouse sperm, correct?
That's correct, yeah.
And so how did you make these mouse sperm protamine deficient?
Our lab generated a protamine 2 deficient mouse line using CRISPR-Cas9 techniques, where we excised the entirety of the protamine 2 gene. And then we mated the heterozygotes with other heterozygotes, and eventually were able to find protamine 2 knockout males to use.
You may not know this, but a long time ago when Kate was a fellow, she worked on a knockout mouse, and I think it took quite a while to develop. So how long does it take you to do this using current technologies?
It depends on the target,
Yeah.
and it depends on how good you are at it. So both my PIs, Will Milish and Zachary Smith, have been incredibly patient and helpful throughout this process of learning how to do ICSI and learning how to do CRISPR-Cas9 within embryos. So I was able to pick it up in a couple months, but yeah.
That's great.
Thanks. I know it
Very impressive.
totally different from previous years.
So tell us a little bit about the phenotype. Once you achieved these knockouts, what did their fertility look like?
Yeah, so we expected there to be a minimal change because the content of DNA is still the same if you remove protamines. The only thing that you're changing is the structure of DNA and the way that it's organized. But instead of that, we wind up seeing that these zygotes arrest at the 2-cell stage and appear fragmented like. And within the first 24 hours post-fertilization, there's absolute chaos that breaks out during that cleavage stage.
Awesome. So how do you see this in terms of its impact or its relevance to our patient population, to perhaps those with male factor infertility, potential future therapeutic targets? What are your next steps?
For the next steps, I would love to see if there is a protamine 2 deficient population in humans, and see whether or not through using embryoscopes, whether or not the embryos are able to properly cleave, or if they also experience this fragmentation defect. Ultimately, we want to try and figure out what is the best kind of sperm that we can be putting in with the best kind of oocyte in order to improve our chances of having embryos that are viable and able to progress further.
That sounds like a great step. So are you already starting to accumulate male samples, or you still have more work to do in your mice?
So I am in the process of writing my dissertation. So a lot of my effort has been focused there, but I'm hoping that after graduation, I'm able to pursue work at an IVF clinic and take this work with me and find out a little bit more in a human population, or to work with other IVF clinics to look into this.
Fascinating. So, I mean, we're so fortunate to have bright young minds like you doing work in, a basic and translational format. Are you thinking that your career will go towards embryology? How do you foresee bringing all this great knowledge to our patients?
Yeah, I would love to go into embryology. I think that embryologists do very noble and wonderful work and would love to be a part of that community. I would also be open to going into biotech because investing in biotechnology and new ways of assessing these kinds of questions and generating new techniques for clinicians to use is ultimately what I think is worth going for and doing.
And if you don't mind my asking, is that a mouse that you have? Is your tattoo on your arm a mouse?
Yes, it is a tattoo of a mouse. I have been working with mice for a very long time, and I appreciate the fact that we are able to have these model organisms to work with.
That's awesome. Yeah, I like the homage to your muse in a way, I guess. So
Yes,
thank you so much for joining us today. We loved your presentation and we can't wait to see next steps in your work, and congratulations on going to your all but dissertation.
Okay, we are back at PCRS 2025 and very excited to have Andria Besser from NYU Langone. And your talk, Andrea, has been kind of the buzz of this meeting so far. You gave a talk on exploring the clinical utility of mosaic and segmental aneuploid PGT-A results. And my first question, one that I wanted to stand up there and actually ask you, but it kind of got to it later with some of the other debates. Did we get it wrong with calling these embryos mosaic using PGT? What do we mean when we say that when we're talking about PGT? Just start us at the basics. What are we talking about when we say mosaic embryos and PGT? And why is that important?
Yeah, I think that we definitely jumped the gun on calling it mosaic. I think there was an assumption because of some of the experiments that were done early on to try to detect mosaicism, these mixing experiments, taking euploid cells and aneuploid cells and mixing them together in different ratios and seeing the output was an intermediate copy number. We jumped to the conclusion that every time we see an intermediate copy number, that must mean that the biopsy is mosaic. When in reality, we now know that there's other things that could cause an intermediate copy number. But it's hard to go backwards. Once the cat is out of the bag, we can't really go back. And unfortunately, the term intermediate copy number didn't really take off.
Doesn't roll off the tongue quite the
Exactly,
same way as
exactly.
mosaic. Yeah.
And I think there's some implications by referring to it as mosaic that aren't always necessarily fact, so I think we did kind of screw up there a little bit.
Okay. So what's changed in the last 5 years? This has been a hot topic in the literature. If you gave this talk 5 years ago versus the one you just gave this week, what's changed? What have we learned?
Yeah, I think that we've really learned, and I think people are starting to understand that not all PGT-A is the same thing. I think for a long time, we've been thinking about it as really one test that has gone through this evolution from the days of FISH through array CGH through NGS. And now that we're at NGS or next generation sequencing, that we've arrived at kind of this final technology and all NGS is the same. But in reality, we now know there have been so many studies that have found different labs having different aneuploidy rates, different euploidy rates, different mosaicism rates. We've learned more about how amplification impacts those different results frequencies. So I think that's been a big learning curve over the last few years.
Well, so another thing that came up at this meeting in the debate that we referenced a little bit earlier as well is that all PGT-A labs are not created equal. And that's something that I know you addressed very eloquently in your talk. Dr. Scott mentioned in his talk, as it is near and dear to his heart, the importance of doing non-selection studies, or maybe we should be calling them diagnostic accuracy studies or something of that nature. Do you agree that all labs need to be doing this? And if so, how do we make that more status quo when it's such a big, expensive undertaking?
Yeah, absolutely. I think it's the one thing that is 100% necessary for every lab to do, because it is the only way that we can get that clinical validation data, the positive predictive values and the negative predictive values of each type of result, to be able to even counsel our patients. I think right now, if we're using a lab that hasn't done that non-selection study and we're using rebiopsy data or retrospective outcome data. I mean, not that that's not valuable, but that's not getting at the real question. For a long time, I think everybody focused on the accuracy of euploid results. What's the chance that this euploid embryo that result is going to be wrong and we're going to end up with an aneuploid pregnancy? And that really is pretty much the same between each lab. We haven't really seen differences there, probably in part because that's just a rare outcome in general. So nobody's worried about these labs' euploid results. It's really the non-euploid results, the aneuploids, the mosaics. We need to know how accurate or how representative is that result, not only of the rest of the embryo, which rebiopsy studies can assess, but of the actual clinical outcomes. So the non-selection study is the only way to get to that. As far as how to actually accomplish that, I mean, I think that should be necessary before a lab actually launches its product, which is very hard to say now that all of these PGT labs are, years and years and years into doing their testing. So how do we kind of go back in time? I can't really comment on where that money would come from, but I think it needs to be held as a priority for sure.
So you touched on accumulating data that's been happening from registries and people reporting these outcomes. Can you just update us on how much data are we talking about of transfer of these mosaic embryos and what kind of outcomes are we seeing?
Yeah, so the International Registry of Mosaic Embryo Transfers, which I'm a part of, we've been collecting data on thousands of mosaic embryo transfers. And largely we're seeing kind of the same thing that we started seeing when we first reported on the first 1,000 mosaic embryos, which is that mosaic embryos have a pretty significant reproductive potential. I think that's no longer something to even debate. We definitely see these embryos make babies. We're seeing very low risks of persisting aneuploidy, which has been extremely reassuring because I think that was a big concern when we first started transferring mosaic embryos, that, okay, maybe we are achieving pregnancies, but if we're doing harm, of course, that's something that we need to be taking into account. So I think that we're showing that we're not doing harm with this, that it is a very low risk.
And then, of course, there's the whole other category of segmental aneuploidies. You and your colleagues from NYU published what I think is a really important paper not too long ago. Tell us what you told the audience the other day about segmental aneuploidies and what should we be doing with those in 2025?
Yeah, so we actually started transferring non-mosaic segmental aneuploid embryos in 2021 was the first time that we started offering that for transfer. And that came out of looking at the rebiopsy studies, the concordance studies showing that the concordance of those results in the rest of the embryo was quite a bit lower than the whole chromosome aneuploids. So that's what got us to thinking, hey, maybe we should be treating these embryos a little bit differently. Those results are definitely more rare than mosaics. So even though we've been doing this for about 4 years now, we had, at the time that we published this paper late last year, we had only transferred actually 25 of them, even though it was over a 4-year period. And we had found 6 live births out of the 25. So that was a 24% live birth rate. Of those, we had 3 patients that underwent prenatal diagnosis, and all 3 were normal. The other 3 didn't pursue prenatal diagnosis, but the babies were healthy. As of now, we've transferred, I want to say, about 32 or 33 of these. And we have a 7th live birth. We have an 8th ongoing pregnancy. So still kind of holding up at that 24% or so. I think there's still so much more data needed. It's not like with mosaics where we've transferred thousands and thousands. I think we don't have a great sense yet of exactly not only the reproductive potential, but the potential risks. But I think one thing that I always want people to remember is that we're usually talking about really, really big deletions and duplications here. They're mainly affecting the embryo's viability. They're not so much, they're not these micro deletions or micro duplications that we would expect to see in a live birth.
So what embryos shouldn't we transfer? Seems like we can transfer everything now.
Well, I think if on a clinically validated platform that shows that a particular result type is not implanting. So for example, in Ashley Teague's study showing that there were 0 ongoing pregnancies and I can't remember the denominator, but of all the whole chromosome aneuploids that they transferred, they had 0 ongoing pregnancies. It doesn't make sense to transfer those. I mean, of course, if the chance is never going to be 0, there's always going to be some margin of error. And I think in that paper, they even said the top limit of the confidence interval was something around, I think it was 2.4%. So we can at least use that data to counsel our patients and say, look, at most, this embryo has about a 2.4% chance of working. If that's something the patient wants to do and, the clinic supports that, that's one thing. But we can't just take a results that has never been clinically validated, that we don't know the positive predictive value, and tell a patient, no, we can't transfer this just because we feel like it's a bad idea. We need data.
Absolutely. And then what about discarding embryos? I think we all have a lot more hesitation today than we did in the past. What kind of advice do you give your patients about which embryos they should be disposing of if their family's not yet complete?
That's a great question. So we actually changed our disposal policy and protocol a few years ago at the same time that we started transferring segmental aneuploids in 2021. What we were doing before that was when the patient would sign their PGT consents, they would indicate their wishes to dispose of their embryos at that point. And what we found was that a lot of patients were signing to discard abnormal embryos because they were just under the assumption that, of course, I'm going to have normal ones. Everybody kind of goes into this with a level of optimism. And even if the statistics are not in their favor, the thought is, well, that won't be me. I'm going to be on the good side of things, which, of course, it's great to have that kind of hope. So patients would go into it thinking, I'm not going to really be in the position where I even need to think about these embryos. They would sign to discard them. And then when they wouldn't have any embryos, they sometimes would panic and think, actually, wait, don't discard my abnormal ones. So in 2021, recognizing this and recognizing the evolving nature of these PGT-A results, we changed our policy that patients no longer sign for disposal directives up front. After they get their PGT results, they're counseled on their results, and then we talk to them about what they want to do with their embryos. And our recommendation generally is, unless they have only whole chromosome aneuploids or they've fully completed building their family, we recommend keeping their embryos frozen. Sometimes that can be a financial burden, so that is important to bring up. But if it's financially doable for the patient, we usually recommend keeping everything until those embryos that we know have a really low chance of working, those are the ones, that make sense to discard. But we haven't been telling them to discard mosaic segmental aneuploids for several years now. And I think clinics really should consider that, because they don't think patients are in the position of making disposal decisions until they know exactly what they've got.
I think it's a huge compliment to you. I think both Richards gave you huge kudos about really moving forward the field in your really broad and wise perspective of how to analyze the results that we get back with this evolving technology, and one that's, both a curse and a blessing in some ways. So we appreciate your talk. I really do mean it when I say I think it's the best talk I heard this meeting. So congratulations.
Thank you. That's a nice compliment. I appreciate it.
Okay, so we are continuing our theme here at PCRS of talking about embryo genetics, and now moving on to carrier screening. So we're here with Emily Patterson, who's also from NYU, colleagues of Andria Besser that we just heard from. She presented a great talk called Beneath the Surface, Uncovering Health Risks with Comprehensive Carrier Screening. Thanks so much for joining us, Emily. Tell us, what was your research question that you addressed with this study?
Yeah, the idea with this study was to quantify the incidence of manifesting carrier risk that was identified through patients using a standardized carrier screening panel at our center. We wanted to look at what is the incidence and also what is the scope of manifesting carrier risk that was identified. And we did so through a retrospective review of the cases themselves from March to September of 2024.
That's fascinating. And we all struggle with these findings when we're really looking for reproductive risk and then uncover something that could actually have clinical relevance for the patient in front of us. What did you find?
Yeah, we found that out of 1,577 cases or patients reports, 26.8 tested positive for at least one gene that was reported as being associated with manifesting carrier status. And then looking more specifically at variant associated risk, we found that 12.2% of patients tested positive for a variant that is specifically seen in the literature to be associated with a personal health risk.
And then you're a genetic counselor, so
A counseling assistant.
I'll give you credit for a genetic counselor.
Claim anything I'm not.
Appreciate that. I appreciate the transparency. Well, how do you think these should be addressed from a counseling perspective?
Yeah, I know that for every patient who is flagged for carrying either a gene or more specifically a variant associated with manifesting carrier risk, is then recommended / required to have an internal genetic counseling, post-test counseling session with our counselors. Oftentimes these risks may have an associated clearance requirement with cardio, nephrology, an other type of follow-up or referral out for extra screening and care.
And do you typically offer PGT-M to these patients if they're, a carrier isolated in the couple as opposed to mutual carriers?
I know that at our center, PGT-M is never explicitly recommended by our counselors. However, in the past, we have had patients who have sought PGT-M for manifesting carrier risk. I believe for ATM was the example that comes to mind. So we have done this in the past, although I would not say it's standard practice.
Understood. Well, I think this definitely adds to the literature. I don't think that this incidence has been reported before. You did have a large sample size. How many samples did you include in your study approximately?
1,577.
Just about.
Roughly, approximately that number. Yes.
Awesome. Well, this is in addition to the literature. We look forward to reading the paper, and it's helpful to know what we expect to see when we get these results back on these always expanding carrier screening panels.
We're here with another one of our favorite oral abstracts from PCRS 2025, and we're here with Dr. Esther Chung from Stanford. And so you gave a really interesting talk on a lower cost protocol. So just tell us about this protocol and why you felt like it was important to look at ways to reduce costs and what patient population you were looking at.
Yes, so thank you guys for having me. I think the Cardinal protocol came out of my desire to increase access to care, especially in the environment I was practicing in. At Stanford, there are a lot of residents, trainees, people who live very busy lives, and even inside and outside of medicine. And so I wanted to come up with a protocol that was more streamlined, but also in the same way would decrease costs for patients, maybe for the clinics as well. And so we spent some time digging into the literature to figure out what is a way to sort of apply all the different cost-saving measures into creating one protocol that I think would still deliver similar outcomes or non-inferior outcomes. So without sacrificing efficacy, but being able to deliver care that is less intense for the patient and satisfactory to the patient.
And so you look specifically at egg freezing cycles, correct?
Yes.
And I think that's a often neglected
Yes.
Treatment modality, particularly when we're talking about cost considerations, because
Yes.
people think of it as almost a luxury,
Yes.
right?
Elective.
Right, elective, exactly.
Right.
So tell us, why did you choose that? And tell us a little bit about what the protocol involves.
Yeah, so fertility preservation was the focus I decided to take for a couple of reasons. I think one reason was from a practicality standpoint of finishing this thesis project of mine and being able to get to an outcome that mattered for the patient. From an infertility perspective, I would have to follow patients all the way to live birth, which would not have been feasible from that perspective. So that's why I decided egg freezing might be the way to focus. And then giving, again, consideration to the population at hand who might want a more simplified protocol. People who are busy, people who are doing egg freezing or not need egg freezing, but are interested in egg freezing as a way for deferred reproduction. I think there were plenty of people who needed that in the Bay Area and also at Stanford. So that's why we chose it for that particular group. And then with regards to your second question about what did we do in the protocol, we decided to do very standardized dosing. So based off of your AMH, you would get up to 225 if your AMH was greater than 4, 300 if your AMH was less than 4 as your starting dose. We decided to use Provera, so a progestin protocol. And in terms of deciding, when to start that, there was a little bit of a debate, but we decided to start it on stim day 6 as sort of a very mirroring ANTAC protocol. We also decided to limit it monitoring to 2 scans, so a baseline scan just to make sure you can start, and a stim day 9 scan, because we almost 100% of the time don't trigger someone before stim day 9. And from stim day 9, we made it so that people would auto trigger. So no one is telling you to come back every single day, stim day 9, 10, 11. It's more that you look at stim day 9, guess where the cohort is going to go, and tell them to trigger at home on a certain date. And so that was sort of, and no labs. Oh, that was probably really key as well. No labs, given that I feel like we can get a lot of information just from the follicles themselves. So that's sort of the protocol.
So the ways you were limiting costs, to just summarize it, you just said no labs, fewer ultrasound appointments, using a progestin rather than a GnRH analog, and having a relatively middle of the road to somewhat low dose starting dose rather than very high dose. Exactly. And those were the 4 targets to reduce costs. That's great. So what did you find when you did these interventions?
Yeah, so we found that the patients who used the Cardinal protocol, so we had, I think, about 70 cycles of patients who used Cardinal, 66 who used routine or chose to the routine option. And we found that the number of mature oocytes retrieved and cryopreserved were not inferior to that of the patients who were in our regularly high intensely monitored antagonist cycles. So
and I have to ask, what was the non-inferiority margin? How much did you?
Yes. I actually, after you gave your statistics talk on the first day of PCRS, I it all rang really familiar to me because I had ruminated over and over again about what the margin should be, what made clinical sense. And there were plenty of papers that had done non-inferior trials and selected 2 or 3 because of what that translates to in terms of live birth. So we strongly considered 3. However, I think doing a little bit more digging into literature on egg freezing specifically, and also looking at egg yields, the variability per cycle for the same patient with the same protocol is high, and you see that in the literature as high as 45%. So that you should not be surprised if a patient who has, an AMH of, let's just say, for example, 1 cycle they get 5 versus the 1 cycle they get 10. That would not necessarily be an, oh my gosh, like that's impossible to believe. So from that perspective, we were like, there is some biologic plausibility that it makes sense. I think that would be clinically acceptable, or not clinically unacceptable if we got beyond 5. Right. 3 would be people would kind of be like, oh, that could just be variability. And then also just taking into the practical nature of, we are trying to bring in a protocol that is more cost saving and also less intense. So, just taking that into consideration as well, we decided we'd go with 5.
And so, I mean, now that you have a fairly compelling data set showing non-inferiority in a prospective observational study, is this something that you think warrants an RCT? And do you think that you can have patients agree to be randomized, or you're satisfied to proceed forward with this protocol in your population?
At the very beginning of this project, like I think a year and a half ago, I strongly wanted it to make it a randomized control trial, but was limited from a cost perspective of having to pay for everyone's cycles in order to make this a reality. And so I think from a feasibility standpoint, this is, I am happy with the level of data that we have. I do think we should continue to monitor, because Cardinal has now become a protocol that is an option for any patient outside of research at Stanford. And so we've been continuing to offer it. And I think after I leave, someone should continue to still monitor those data. And then I think it also has opened the room to letting providers feel a little bit more comfortable applying progestin protocols for their freeze-all cycle. So that has also been a big change for us. And I think having experience with the Cardinal enabled our providers, all 10 or so of them, to be more open to trying these cost-conscious protocols. So I think we're heading in a good direction, but I would love to continue to see other centers, other studies try this protocol. I will say the generalizability of this study, interestingly enough, the patient population, about 40% were Asian, which is reflective of the Bay Area, but at the same time, I know isn't reflective of the rest of the United States. So that is something that, I think could be interesting to be done at other places as well on potentially a bigger scale.
Well, especially at this time where we have a mandate from an executive order to increase access to IVF, anything that we can be doing that doesn't harm our patients' outcomes and potentially decreases cost and the imposition on their lives is a huge win. And I personally am always happy to see any data that is, pointing towards using MPA protocols that have been so slow in terms of uptake for our patients, even though the quality of the evidence is very, very good. So thank you for doing this important work, and hopefully it can be thought-provoking for a lot of our colleagues and see sometimes less is more.
Yes, sometimes less is more. And thank you again for having me. I love this conference, and I was really grateful to have the opportunity to present.
Okay, so we're here in PCRS. Dr. Howie Lee just came from the pool. He's a fellow at the NIH, and he presented an excellent study entitled Microwave Drying and Storage of Human Oocytes, or paraphrased as microdry. This was actually his co-fellow's work, Dr. Ariel Dunn. Dr. Lee is doing some similar work as well, so maybe he'll tell us a little bit about that. But first, let's talk about this amazing study that you presented the other day, or was it yesterday? Was it this morning?
It was yesterday.
Time flies at PCRS. Okay, tell us about it, Howie.
Yeah, so this is a study looking at the feasibility of using microwave drying for long-term storage of human oocytes at ambient temperatures or non-freezing temperatures. This is technology that has actually been developed, is being developed in the field of conservation biology for storing gametes of often endangered animals in low resource settings, often where storing at ambient temperatures might be beneficial. And our group has shown that we're able to store spermatozoa and oocytes from animal models through this drying at non-freezing temperatures. So this was the first study to try to apply this technology to see if they could feasibly demonstrate that this method might work in human oocytes.
Okay, well, that's exciting. I mean, talking about conservation of large cats, but then also being able to do conservation, or it's not cryopreservation, but rather just preservation of human gametes in resource poor settings. There's so many applications for this technology. So tell us a little bit about what you found.
Yeah, so the technology that we developed involves a process of first permeabilizing the gametes, oocytes in this situation, and incubating them in a sugar called trehalose, which actually is a cryoprotectant, but also helps preserve the integrity of macromolecules and cellular structures during the dehydration process. And we had over 300 oocytes that we between our control group and a variety of dehydrating conditions. And we found that when oocytes were either dehydrated and immediately rehydrated versus stored at 7 days versus 28 days, 4 degrees versus room temperature. In all of these conditions, the extent of DNA damage was actually quite comparable to fresh controls.
Okay, so what outcomes specifically did you look at?
Yeah, the main purpose of this was to look at DNA integrity. So our final outcome was the result of the tunnel assay, which is a fluorescence-based assay that looks for exposed nicked ends, specifically exposed 3' ends. And we were measuring the normalized signal intensity of the tunnel assay after rehydration and fixation.
Okay, and so in terms of the tunnel assay, is that something that you feel has clinical applicability? Why did you choose that particular assay?
Yeah, I think there are several goals for long-term gamete preservation, but one of the most important ones is to preserve the DNA integrity. DNA fragmentation is a very important marker of gamete quality, both for sperm and oocytes. It is actually something that we use quite commonly to assess DNA fragmentation in human spermatozoa. So it does have clinical relevance in that regard, and it is a pretty reliable assay to look for exposed 3' ends in cells.
And I know you also reported just on recovery upon rehydration. What do you mean by recovery?
Yeah, so we have a starting number of oocytes that we take through the desiccation process. And after a storage period of either 7 days versus 28 days, we rehydrate them and fix them and attempt to visualize them. So the recovery is how many oocytes we're actually able to recover and visualize on microscopy versus how many actually disappeared. And what we found is that in all the conditions tested, we had over 90% recovery of the starting oocytes.
Well, I mean, I can think of the applications of this technology as just being massive. We think about all of the space resources that we need, the liquid nitrogen, the tanks, the real potential for loss of really invaluable reproductive materials when we're talking about cryopreservation technologies, even including vitrification. How do you actually store these? Can you just put them in your kitchen cupboard? When you have a desiccated gamete, what are the conditions that they need to be kept at?
Yeah, there are a variety of storage techniques that have been explored. For us, we actually just simply, after we had desiccated our gametes, we just store them in a moisture barrier bag, which is just a little silver envelope that can be in your drawer if you're storing at room temperature, or put it in the fridge.
That's amazing. And so what are next steps? How are we going to evaluate when this is ready for prime time?
Yeah, so there's a few future directions that our lab is exploring. Like my specific project actually that I'm doing in this lab is looking at human sperm, and to see if we can also optimize this technology for human sperm, which is a very exciting direction because we actually have been able to demonstrate the ability to create embryos from sperm that has been stored in this process. When it comes to oocytes, one of the main limitations is that we were using immature oocytes for this study, which is not directly clinically applicable to the way we do IVF today. The other limitation is that our method of delivering trehalose, which is our kind of desiccation protectant into the cells, involves membrane permeabilization. So we're also exploring other ways to deliver trehalose into these gametes in ways that don't disrupt the membrane.
Wow. And were you limited to immature oocytes just because of availability in terms of what perhaps an IVF lab had left over?
Correct. Yeah, we wanted to start with fresh oocytes, the best source of fresh human oocytes, and the best source of this were patients who were actively going through IVF. And as we all know, these are very precious specimens. So we actually, our specimens were all immature oocytes that have demonstrated failure to undergo maturation after 24 hours using IVM. And only then would we take those eggs, those oocytes, which were ultimately deemed for discard for use in our study.
Well, really look forward to more work coming out of Dr. Kamazzoli's lab. I've been excited over the last really 5 years about all of the work he's done, and it's amazing to see it progress from non-human models to human models. I really think that it holds a lot of promise for being able to make IVF more accessible globally.
Yeah, and one of my favorite aspects of this project is that this is technology that was developed for conservation biology, and it's so special that this technology can have also benefit for improving the accessibility and affordability of IVF for humans.
Absolutely. All right. Well, thanks for joining us, Dr. Lee. Get back to the pool
Thank you so
and
much.
enjoy the rest of the amazing science here at PCRS.
Thank you, Dr. Devine.
Okay, well, thank you so much to our listeners for tuning in for this on-site special episode of FNS On Air. This was my favorite PCRS yet. There's been a lot of really exciting talks specifically on the genetics front, so everybody should think about coming next year. It really is not to be missed.
This concludes our episode of Fertility and Sterility on Air, brought to you by the Fertility and Sterility family of journals in conjunction with the American Society for Reproductive Medicine. This podcast was developed by Fertility and Sterility and the American Society for Reproductive Medicine as an educational resource and service to its members and other practicing clinicians. While the podcast reflects the views of the authors and the hosts, it is not intended to be the only approved standard of practice or to direct an exclusive course of treatment. The opinions expressed are those of the discussants and do not reflect Fertility and Sterility or the American Society for Reproductive Medicine.